math humans. We're going to do the last section of chapter 2 today. We're going to be talking about polynomial inequalities. Our objectives are that we're going to solve those inequalities graphically, and then we're going to report with interval notation. I will tell you that the book does this differently, and I am going to choose to ignore the book's method because I know what's coming when you get to calculus. So we're actually just going to start with an example, and I'll explain some information as we go along. A polynomial inequality might look something like this. And so a polynomial, a function, is going to be either above or below the x-axis, and that's where the inequality portion of the graph comes in. So if I want to know when is a function less than 0, that just means where is the function below the x-axis. And if f of x is greater than 0, that means where is the function above the x-axis. And then if I include an inequality, or the equality sign, sorry, brain and mouth aren't working at the same speed, that just means then I get to be below and at the x-axis. So I would include the x-axis when I do this. So basically what we're going to do is we're just going to factor. So this is an x minus 3 and an x plus 1 is less than 0. Because what that does is it helps us to find the zeros, because I'm going to need those for reporting. So I have an x-intercept at 3, and I have an x-intercept at a negative 1, and I'm going to sketch the parabola. And it doesn't matter how accurate it is, because I'm basically attempting to find out where the function is located. I don't need to know precise information. This particular problem said, where is f of x below 0? Well, if you'll notice, this is the portion of the graph that's below the axis. So I would say that it is from a negative 1 to 3. The endpoints are not included because I did not have the equality statement here. And that's really all there is to it. Let's do, I think doing it this way, which has ramifications for calculus later in your math life, is polite because it sets you up for success in calculus instead of taking a baby step and doing it a different way. So for our next example, I'm going to again start by factoring. This is x plus 2, quantity squared, and I want to know where is that greater than 0. So notice that I get x is equal to a negative 2 with a multiplicity of 2. So I'm going to graph my function. It's still just a cute little parabola. I have this at a negative 2. My leading coefficient is positive, so I know that the parabola is going to bounce up instead of bounce down. And this is, where is the function greater than 2? It doesn't have the inequality, so it's greater than 2 here, and it's greater than 2 here. So the negative 2 is equal to 0, so technically it's not included. So I would say that the function is greater than 0 from a negative infinity to a negative 2, not included, unioned with 2 to, a negative 2 to positive infinity. Alrighty. I have a couple of more examples for you, and then we are done for today. Nice short video. Woohoo! So for the third example, I have 2x cubed minus 3x squared minus 32x is greater than or equal to a negative 48. Nothing like just jumping right in. So I'm going to move this to the other side. 2x cubed minus 3x squared minus 32x plus 48 is greater than or equal to 0. And then I'm going to solve this particular function by grouping. And so in the first one, I'm going to take out an x squared, and I get 2x minus 3. In the second one, I'm going to take out a negative, because this is a negative 32, a negative 16, and I get 2x minus 3. Well, that was polite. So then grouping, I put those two terms together, and x squared minus 16 together. And I need that information to tell me that x is equal to 3 halves and then plus or minus 4, and that comes from this piece. So then I'm going to put all of that information on my graph. So I have a negative 4, 3 halves, and a positive 4, and it would be okay to use your grapher to help you. And this is a cubic function, so it's going to cross here, here, and here. And now we're going to answer the question. So we're looking for where is f of x greater than or equal to 0. Well, it's greater than here, and it's greater than here. Really pretty simple, but this time the endpoints are included because of the equality sign. So I'm going to say that the function is greater than or equal to 0 from a negative 4 to 3 halves included. And then it's going to be from 4 to positive infinity. And I always have to have an open bracket on infinity. Again, these are just really cool little problems, and they don't take very long, especially when you have so much knowledge about how to find information out about our polynomials. Well, now we're going to do a cool one, because now I have this situation. And there are two different ways to do this problem. I'm going to take the approach of managing the 0. So I'm going to change this to be 2x minus 7 over x minus 5 minus 3, and I'm going to leave some space because I have some math to do, less than or equal to 0. Because then I think it makes the inequality a little bit easier. So to be able to put these two rational functions together, I'm going to multiply this one by x minus 5 over x minus 5. Because I can multiply any equation by 1, and I just get to choose what that 1 looks like. I'm going to distribute and do this math. This is 2x minus 7 minus 3x plus 15 over x minus 5 is less than or equal to 0. I'm going to simplify this. This turns out to be a negative x plus 8 over x minus 5 is less than or equal to 0. And so now I know a lot of information about my rational function. I know that I have a vertical asymptote at x is equal to 5. The degree is the same top and bottom, so y is equal to a negative 1. And then my x-intercept is going to be a negative 8x plus 8 equals 0. A negative x is a negative 8 at x is equal to 8. So my x-intercept is going to be at x is equal to 8. So I actually can go ahead and sketch this graph because I know so much information. My vertical asymptote is 1, 2, 3, 4, 5, and it's here. My x-intercept is going to happen, my graph's not long enough, at 5, 6, 7, 8. I'm going to put a dot there. My horizontal asymptote is at a negative 1. And then it's also polite to use your calculator to make sure that you confirm these curves, that you get them in the right location. And it's going to look like this. So now I can answer the question. The question was, when is f of x less than or equal to 0? Well, it's less than or equal to 0, all of this curve and this curve. So it's going to be less than and equal to 0 from a negative infinity to a positive 5, okay? The 5's not included. And then it's going to be less than or equal to 0 at 8 to positive infinity. So it's actually really pretty simple. And that's it for today. I will see you soon.